Hello everyone, my name is Ido Guo. I will share you our team's newest work for continual learning and CVPR2023. Okay, our paper's title is Dealing with Cross-Task Class Discrimination in Online Continual Learning. Okay, in our paper, we focus on the class increment learning setting. In the class increment learning setting, okay, the new class appears incrementally, and the model needs to classify all things class without providing the task ID. And we focus on the replay-based method. In this method, our system will store a limited number of training data of previous class and replace the stored samples with the new training data of new class to make the model can learn knowledge of new task, while avoiding to forget the knowledge of previous class. Okay, let's start. We focus on the class discrimination problem. Okay, this challenging is to establish decision boundary between class from different tasks. That is different to the traditional continual learning challenging the balance problem between stability and plasticity. Okay, the stability problem means that we need to maintain the established decision boundary between previous class, and plasticity problem means that we need to establish new decision boundary between new class from the new task. Okay, and our challenge is to establish decision boundary between previous class and the new class. That is very challenging. Okay, the replay-based method can mitigate this problem by mix the training data of previous class and new class and use the mixed training batch to train the model. However, we found that the replay-based method still have problem in establish cross-task decision boundary. That is the imbalance problem. Okay, we cover the imbalance. I describe the imbalance problem from the two aspects. One is the data imbalance. Okay, after learning lots of tasks, the average data number of the previous class in the training batch is usually very small, but the average training data of a new class in the training batch is usually no change, and then the model will see more training data in the training batch, more training data of new class in the training batch, and then it will have a bias toward the new class. Another imbalance is the continual learning imbalance. Okay, we cover this imbalance use the gradient rate. That is, okay, the model has seen the stored buffer data many times, but it is the first time for the model to see the training data of a new class. Okay, so the gradient, the logit of new class usually is bigger than the logit or the gradient of the previous class, and use the gradient rate tool, you can see that okay, the gradient rate of the new class is usually bigger, and the previous class gradient rate is usually smaller, and then that means the model have a bias toward the new class. To solve the imbalance problem in the replay-based method, we first propose a general continual learning classification optimization framework that decouples the traditional cross-entropy classification optimization framework. Okay, our framework considers the plasticity problem, the stability problem, and the cross-task class discrimination problem independently, and then we propose a data imbalance sampling strategy to ensure that the data number of each task, each class in the training batch is the same, and also we propose adaptive loss to mitigate the self-imbalance. Okay, actually we adjust the weight of each class data based on its gradient rate to make sure the balance between each class. We verify our method on 4 different data sets, and you can see that our method achieves the best performance. And also our method is orthogonal to previous research work that focus on the forgetting problem. So their system also can be deployed into our system, and then the combined system can achieve better performance. Also, our method reduce the gradient rate of the new class and make the gradient balance between and try to make the gradient balance between all thin class. But our method doesn't fix this problem. Okay, so we encourage the research to focus on the imbalance problem for the cross-task class discrimination challenging. Okay, that is what I want to share with you. If you have any question, you can email me. You can send an email to me. Thanks.